डेली लीड कोड प्रॉब्लम is maximum sum circular subarray. Okay, so you have done the question of maximum sum subarray. It's a pretty standard question of Kadane's algorithm, and there are multiple ways to do it as well, like DP and using prefix suffix also. So you can do it in O of n. But this is something, a pretty good question, right? Because why you have been included the thing like circular subarray, right? So that makes it something like, kind of tricky. So you have been given a circular integer array. Do you know what is circular integer array? When the last element is connected with the first element and so on. Basically, this after this minus two, one is placed. You can say like yeah, so it's moving in a circular fashion. So return the maximum sum of a non-empty subarray of nums, right? So this is just not a normal subarray. Like in this case, this is not just normal array like 5 3 5 minus 3 5. In this case, like this 5 is also connected with this 5, so you can say this 5 is placed after this, and this minus 3 is also placed after this 5 in this case. So yeah, this is basically something like uh, circular subarray. Now when you see sorry, circular array. Now when you see circular array, the basic some standard approach of this doing this quotients are, just when you repeat the repeat the elements, like when you repeat the elements again, like of the array, when if you repeat the elements again, so now you will have all the possible arrays and sub arrays possible, because there would not be any other case left, right? Because this is the maximum sub array in this case. You can take okay, length would be still greater than. And okay, so now let's see what we have to do in this circular array which we get, and connects the beginning of the array formally. The next element is this modulus n and subarray, and yeah, you need to return the only good thing about this is, subarray is only including each element only once. Okay, so buffer can store nums, each element of this nums exactly once. So I'm writing it two times, it doesn't mean that it is stored as two times. You can see, like, if you are including, now you want a subarray, if you are including this element in your subarray, you cannot include its replica into the same subarray. You cannot just make your subarray of size greater than 3. So in this you can pick any subarray of the size at most to 3. So that is the whole answer for this question. If you can somehow do this question in this way, that is also the one of the possible solution. Ki max subarray sum with the subarray size less than equal to 3. Okay, this is the answer for this. You have to see all the possible subarrays having the size less than 3, and then but that is n square time complexity. If you just go one by one all the subarrays of size 3, other way is just a sliding window, and then that you can do. But there are some edge cases that you need to handle. And then now let's talk about the approach for this problem. What we will be doing this, for example, if you have been given a subarray like this, array like this, 1 minus 2 3 minus 2. Now how there are two ways that the maximum subarray sum will be coming out. If it was just a normal subarray, then there is only one way. If it is circular subarray, then there are two ways, right? Let me draw that two ways. One way is just it's normal Kadane algorithm. On the basically you are treating that this is not a circular, it's just a normal subarray, because that maximum length you can take is only 4, right? So one way is just normal subarray. Keep this as normal array, right? Array, and take the elements like this is my how you, in the normal array, what is your subarray? Subarray is just this element, or these two elements connected together. And in this is a case of when you can some takes uh, we are going out of boundary subarrays. So we have to handle for out of boundary subarrays. Some subarrays are out of boundary, but still they are good subarray, and some are just normal subarray, right? So let's talk about what I'm saying by out of boundary subarray. Normal subarray is just like these subarrays which can form like 1, 1 minus 2, 1 minus 2 minus 3, and so on. Out of boundary subarray is when you're including 1 from this side and minus 2 from this side, and you are not including these two, right? You are just including this minus 2, and then because like then you are including this 1 again. So this is a kind of a boundary subarray when you are going out of the boundary. So we'll be calculating the two, and we'll be returning the marks of that. Okay. So max of these two possibilities. Okay, this is P1. This possibility is, let's say, P1, that your array can subarray can be out of boundary, or subarray can be a part of a normal subarray, right? So max of P1 comma P2. So P2 answer we already know. P2 is equal to Kadane's algorithm, because Kadane's algorithm can give us I don't know spelling. So let's say Kadane's, I think C, yeah. No, don't know what. Yeah. So Kadane's algorithm, or maybe we can search about that. Kadane's, yeah, any Kadane algo, and then it's like Kadane's like that. Yeah. The P1 is just out of boundary subarray. Now you have to do this. Up now you have to form logic that you are only dealing with out of boundary subarrays. Some elements from the beginning, some elements from the ending. How you can take that? You can take that in multiple ways. Let me just give you an idea about this. Like 1 - 2 and 3 and -2. So you can take a subarray sum, like this. Subarray sum is just continuous subarray, right? So you can take any length from this side and any length from this side. Yeah, but you should not, I and j should not, yeah, collide or something like that. Hmm. For this subarray you can take, and these subarray this elements you can take into subarray. And if you take this only one, and you can take this -2, this is also subarray. Good subarray, right? Out of boundary subarray. How you'll deal with all of the out of boundary subarrays? Okay, it's not like much of a task, because what we can essentially do is, remove some of the elements from this side, and then remove the some elements from the middle part. And if we remove some of the elements from the middle part, whatever you will get, or if we remove a normal, yeah, it is a complementary. The good thing about this out of boundary, it's a complementary of the normal subarray. What I'm saying, complementary of some normal subarray, right? Because if you are want the out of boundary subarray like this, -3, sorry, 3 - 2 and this one, then this sub array, out of boundary sub array, is complementary part of this sub array, -2. And any other, if you can take any other out of boundary like this 1 and this -2 is a complementary part of this 3 comma -2. How you can deal with that? You can just say that, I'm just removing this part from the array, and whatever I'll get is the out of boundary sub array. Now this also you have to do intelligently. The smart work should be, because you want out of subarray to be maximum, out of boundary subarray to have some maximum. So you will choose the inner subarray having minimum. Okay, so choose inner subarray with a minimum sum, right? Okay, this is the next thing, the next logic, basically next observation. Now to find a minimum sum subarray, like you inner subarray or you normal subarray, basically, because all the inner subarrays are normal subarray, even if they are starting from the beginning. This is also inner subarray, normal subarray, right? And this is also a normal subarray, right? And yeah, so that is no problem in that. So choose a normal subarray with a minimum sum. So this you have to do, and if you found that minimum sum, then the out of boundary subarray, complementary out of boundary subarray would be total sum minus that, right? Then the complementary out of boundary subarray is equal to total sum minus that normal subarray which you are taking. Now, for example, if you're taking this normal subarray, the out of boundary subarray would be -2 and 1. How you can calculate that sum? You know this sum, you know the total sum, you can just subtract this. So that's what we are doing. Now let's implement our logic. This is all logic about this problem. It is pretty decent problem, because you can go in some wrong directions, and then this is the correct logic that you should know. Like the first thing that you should come into your mind is, if you have been given a array, how many ways are there to choose a sub array having a maximum sum? One, and if this is a cyclic array, how many ways you can choose the sub array having maximum sum? Only when the sub array cannot have duplicate elements again, like not duplicate elements, like this one cannot be again. So then otherwise the answer for this would be 4. But yeah, the answer for this is still 4. Okay, but yeah, this is the thing, like you cannot uh, take Subarray greater than length n. So for that, what you have to do, you have two cases only. One is the normal subarray, and which is obviously the normal subarray you can obviously take, and some of out of boundary subarray which are not included in normal subarray, like 3 and 1 in this case. So for including that, you will have to minus some of the inner subarray, normal subarray, and take the boundary subarray will be the total sum minus that. So this you have to minus which is having the minimum sum, right? So now let's find out that it's not a big of a do. So let's do that. Okay. And we'll do reset the code. We'll paste this for the reference. Let's just comment it up completely. Yeah, now it's fine. So the thing about this is, first let's apply normal Kadane algorithm. So P1 possibility is equal to Kadane algorithm on this nums. Okay. Then the second algorithm, second part of the solution would be calculating the out of boundary subarrays. This is also similar. Just you have to do a Kadane algorithm in the reverse fashion for the not in the reverse fashion, but for the minimum sum. Right. For minimum sum, your sum starting from zero, your minimum sum you are creating, it would be initialized with something. And but the thing is like you will be s plus equal to, it's normal thing, s plus equal to nums of I, and this, and mn is equal to minimum of the normal mn comma s we are getting. And if your sum becomes negative, then not if it becomes positive, in that case we take positive and negative, in this we get positive, sum equal to 0. So now this will give you the good thing. Just you have to initialize your mn with something like, from what you can initialize your mn, you can initialize it as 0, so that sum would always be lesser than 0. But if the yeah, I think it should work. And then, but initially I initialized the sum with a negative element also. Okay, okay. Now let's focus on total sum, because total sum also which you need. So total sum into t, I'm showing is total sum is accumulate nums dot begin. Actually, what I'm saying is minimum the lower limit. Okay, so basically minimum, will at least not at least, but it can at max be your minimum element, min element. Because for example, what I'm saying over here is, if there are some -6, then 1 comma 2 comma 3 comma -4, minimum element of this is -6. Okay, so your minimum cannot be greater than -6. Okay, so minimum is -6. You can initialize your minimum with -6. Even if you initialize your minimum with 0, I think it should work. Otherwise, if it don't work, we'll do this. But and there would be cases, and it can go beyond. Obviously, it can have more. Minimum is lesser, can go lesser than -6. Like in this case, it can go something like -13. That is also good, but it cannot go greater than -6. You know what I'm saying? That is a thing, but I think it should work. And then t is equal to accumulate nums dot begin dot end into a something like 0, and then we'll say ki, okay, now there is comes the thing. If your all elements are negative, what will you take? Okay, there is also the simple boundary case. uh, Not the simple, but yeah, just one boundary case is when all elements are negative. This is also not a boundary case, you can just handle it, just complete it with this code only. -2, -3, -4, what should be the answer for this one? It should be the minimum, sorry, the maximum element present, like, which is -2. How you'll do that? Your kden will give you -2, and your this minimum wala part will give you, total sum is equal to total kden. P1 is equal to -2, you have already. Total sum you have something like, something like 2 4 3 4, which is 9, right? -9, you have total sum. And what this minimum subarray sum will give you? Minimum subarray sum will also give you -9. So when you take the what is the when you take what is the best sub array out of a boundary sub array, he'll say there is no out of best out of boundary sub array. Yeah, that is also the good thing. He's saying that there is because I'm doing total minus minimum, it will give me 0. P2 possibility as 0, which is yeah. So you have to take minimum of that. In that case, you have to take maximum of that, because you are trying to get a maximum subarray. But in this case, if you take the maximum of that, that would be a problem. Why that would be a problem? Because yeah, maximum would give me zero. Zero means you didn't take anything, so but the answer is still -2. That happens with the cadence algorithm also. So like, this maximum minimum element is this one. So there's only the case, like, if all negative. How you can see all negative? It's simple. If t is equal to mn, like all negative, hmm, then you'll say ki return your p1, whatever your this is returning. Else you'll return max of p1 comma p minus mn, because that is what he is giving me. Oh man, I think now it should work. Let's just test it once. Kn is not declared. Okay, so let's make a Kn cadence algorithm of vector of int and percent, let's say a, and s equal to 0, mx equal to -1 e9. Like Hawkeden algorithm for auto I in a, you can just s plus equal to a and not I, and then you can just say key mx is equal to max of mx comma s, and then you can say if s is negative, then you will do s is equal to 0, and you have to return s. I think that should work. N is not declared, I think so. Nums dot size. Anything else? I don't think so. Okay, 2, 3, 15. Okay, so it should give -2. Why it's not giving -2? Mx is equal to this, mx is equal to max of s. Okay, s is equal to 0. S plus equal to I, mx is equal to this. In this case, this cadence will give us, a good thing. I don't think so. Cadence is giving us any wrong thing. T is equal to mn, mn is 0. Okay, so -2, 10, 10, 15, 2. Why it is giving us 2? It should give us 3, because answer is given. Maximum of this p1 is cadence on nums, and then let's see what is p1 and p2. See p1 and, because in this case cadence should give us 3. Why cadence is not giving us 3? I don't know. Okay, why cadence is giving us 1? That is like it's problem in our cadence algorithm. Are you saying that? 115. Why cadence is giving us 1? For order I in A, s plus equal to I, and mx is equal to this. It is 0 and order I. Sum plus is equal to, that part, like 1, and then mx is equal to this. Mx comma s. S is equal to 0 if it becomes negative. How Kadane is not giving me correct answer, yeah. And for auto n, s plus is equal to I. If s goes negative, then s is equal to 0. Okay, let me just take the Kadane from here, because I have written Kadane is not something like which should be wrong. -1 e9 is plus equal to this. What is problem? Max of this, return s. What is the issue? Same Kadane algorithm. Now it is giving me right. What is the difference? But mx equal to -1 e9 and s is equal to 0 for order I in A. S plus equal to I, mx is equal to max of that is equal to 0. What is this, man? Why it's wrong? That Kadane and okay, return mx you have to return, yaar. Oh, max Subarray sum. Okay, that was the pretty bad error, you don't have to return your last sum. You have to return the maximum sum you have found so far. Okay, that is the normal Kadane logic. Okay, so that is all about it. Okay guys, bye.